In this video, we're going to be learning how to divide rational expressions. So when we divide rational expressions, we're really using our knowledge of how we divide fractions. And we know that when we divide fractions, we can turn any division problem with fractions into multiplication by simply multiplying by the reciprocal of the second fraction. So here we can take a over b divided by c over d, turn it into multiplication. So it becomes a over b times d over c. So notice we did the reciprocal here and flipped the fraction over. And then we would just multiply and then simplify. So it's really very similar to multiplication. What we're going to be doing is we're going to turn the division problem into multiplication by multiplying by the reciprocal of the second fraction. And then from there, just use our multiplication tricks. So let's take a look at our first example here. What I note is that I have a division problem. So when I have division, I'm immediately going to note that I need to rewrite this into multiplication. And in order to rewrite it into multiplication, I need to multiply by the reciprocal, or the flipped fraction, of the second one. So I leave the first fraction completely alone. I multiply, so you can use a star or a little dot, by the reciprocal of the second fraction. So what that means is I'm going to flip it over. So basically we keep the same, we switch division to multiplication, and then we flip the second fraction. So here we have 8x cubed y to the 7th now in the numerator, and then we have 10x to the 4th y squared in our denominator. So from here, we're now going to use our multiplication, which means we multiply straight across. So 12 times 8 gives me 96. X to the 3rd times x to the 3rd gives me x to the 6th. Y to the 4th times y to the 7th gives me y to the 11th. Then 5 times 10 gives me 50. X squared times x to the 4th is x to the 6th. Y cubed times y squared is going to be y to the 5th. So now from here, this just comes down to simplifying. So I can use exponent properties here to help me simplify, as well as my knowledge of simplifying fractions. So I know both 96 and 50 are divisible by 2, so that leaves me with 48 over 25. I then see x to the 6th over x to the 6th. Well, those completely cancel out because they're identical and exactly the same. And then, so we're left with no x's in the whole problem. And then we have y to the 11th over y to the 5th, so we can take 11 minus 5, and that leaves us with 6, so we have y to the 6th in the numerator. The other way you can write this out, if you would like, is you can write the y to the 11th out as y to the 5th over y to the 6th, so you would have that instead for the y's, and then you would see the y to the 5ths cancel, and we're left with y to the 6th in our numerator. Regardless of the strategy that you like to use, our final answer will be 48 y to the 6th over 25. So let's take a look at one more example here. So here I notice that I have a division problem. So the first thing I'm going to do is rewrite this into multiplication. So here we have x squared minus 1x minus 30 left alone over 4x squared plus 20x. So we leave the first fraction completely alone. Then we're going to multiply it by, we're going to flip this second fraction. So we switch to multiplication, and we flip to the reciprocal of the second fraction. So this becomes 12x cubed minus, or x squared, excuse me, minus 16x over x squared plus 2x minus 48. So now that we've rewritten this into multiplication, we're going to use our multiplication solving strategies to simplify this. So we're going to start off by looking at the trinomial here that I just starred in red. We take a equals 1, b equals -1, and c equals -30. So we need two numbers that multiply to -30, add to -1. When we do that, we find that we have -6 and 5. And because a is 1, we can use our a value shortcut here to just rewrite that to be x minus 6 times x plus 5. So we've taken the time to rewrite that one, so we're all done. Then we look at the one straight across. So this one I notice has two terms. They both contain an x and they're both divisible by 4. So I can factor out a 4 times x. And then I'm left with 3x minus 4 inside parentheses. So that one's factored out using the greatest common factor. Now if I take a look at this one, I notice that again I have a greatest common factor of 4x. So I can factor out a 4x here. And then I have x plus 5 inside of my parentheses. And then finally, on this last one over here, I have a trinomial. So I'm going to look at a equals 1, b equals 2, c equals negative 48. So I need two numbers that multiply to negative 48 and add to 2. Two numbers that multiply to negative 48 but add to 2 are 8 and negative 6. So I can rewrite that one because a is 1. I can use my shortcut to be x plus 8 and x minus 6. So now we can combine all of these into one large fraction because we can use multiplication. So let's multiply straight across here. So we have x minus 6, x plus 5 times 4x times 3x minus 4 over 4x times x plus 5 times x plus 8 times x minus 6. Then I'm going to cross off whatever they have in common, and if I cross off anything in the denominator, I'm going to make a note of that because I need to know that that can't equal 0 because of how denominators work. So first thing I notice is x minus 6 gets crossed off, so I know that x minus 6, I need to note when that equals 0. So I know that x cannot equal 6. Then I also note that x plus 5 can get canceled off. So I need to note when that equals 0, which means x cannot equal a negative 5. I then also note that 4x can be canceled off. So we have 4x can't equal 0. So we divide by 4. So I know x cannot equal 0. So here, what I'm left with as my final answer is I have 3x minus 4 in my numerator. I have x plus 8 in my denominator. And then I note x cannot equal 6, negative 5, or 0.